This problem says find the equation for the ellipse given center at 1, 2, vertex at 4, 2, and contains the point 1, 5. And it wants us to graph this. So just like when I start most of these problems giving this information, I'm just going to graph it so I can get an idea where everything's at. So first off, I'm going to graph the 1, negative 2, or 1, 2, excuse me, positive 2. Okay. And then I'm going to graph the 4, 2, which is the vertex. So I'm just going to put a little C there so I know what it is. And then when I go over 4, that's going to be here. And that's going to be my V for my vertex. And then I'm going to graph my 0.15. So there's 1, 2, 3, 4, 5 is up there. And what's interesting about this problem is this is my major axis here. So if I run it this way and this way, that's going to be my major axis. And this distance here is going to be 3, right? Because keep in mind I'm at 1 here, and I'm going all the way over to 4, so that's a distance of 3. And then also going this way, if you notice, I'm starting at 2 and I'm going up to 5. So that's also 3. Wow, weird. So it looks like my A and my B are the same. They're both 3. So that's an interesting result we get from this problem. So understanding that is a big help when I'm actually setting up my equation. And honestly, we get our equation straight away. So that's going to be an easy part of this problem. The graphing is going to take us a little bit more time, but for this, we get the equation. X squared over 3 squared plus y squared over 3 squared equals 1. But that's not complete altogether. We also have a center of 1, 2. But we're almost done. This was not a tough part of this, but to get this part, essentially, my x went to the right one, didn't it? And then it also went up in the y direction too. So those are both positive directions. So that means for my equation then, I'm going to get an x minus 1, because I shifted to the right one. And then my y is going to be up 2, so minus 2 squared. And then again, those are both over 9. So there's the equation. So that's it exactly. Don't forget, originally this was our original equation where we're basing all of this from. And then this is just a shift over. So I want to handle each piece individually so you kind of understand where everything's coming from. So now, with the points that we have, we hopefully understand the symmetry of all of this too. So that means if I go in this direction, if I go in this direction 3, that means I also have to go in the other direction 3 to get the other vertex, because there's 2 vertices here. So that's going to be 1, 2, 3. So it's going to put me here. Oops. I am up a line, so you got to be careful when you're graphing. Okay, so there it is. And then I'm also going to go down 3, because if you look at this value here, that's also a value of 3. So then I'm going to go 3 in the other direction. So 1, 2, 3 is going to put me down there. And then if I actually draw this ellipse, notice what we get. Which this ellipse turns out to just be a circle. And this is a circle of radius 3. We are missing 2 components though, so we can't say we're completely done yet. We still have to find the foci. And again, to do that, I'm thinking of b squared equals a squared minus c squared. So my B and my A are the same, right? Because the longest and shortest side are A and B, and they're equal. So this is going to be a 9 equals a 9 minus C squared. So when I move that over, I'm going to get a 0. So C squared equals 0. So C equals 0. So the distance from the center is actually 0. So this is actually a complete graph, and my foci are both at the center. Because remember, I go to the right C and I go to the left in C. So that means I'm going to get the same value. So my foci are the center. But it asked me for this one. It asked me for the equation, which is here. And then it also asked me to graph it, which is here. So we're done.